Okay, what if gravity isn't what we've been taught it is? What if it's not some fundamental force of the universe, but an illusion? Today, we're going to dive into a pretty radical new theory of gravity. And the wild part is, it didn't come from a university lab or a decades long experiment. It came from a conversation, an idea that could honestly reframe our entire understanding of, well, everything. And it all started with this one sentence. So simple, so provocative, and it flies in the face of a century of physics. The idea that this force we feel every single day isn't a fundamental property of matter, but something else entirely, an effect that emerges from a deeper process happening all around us. Now that is a huge claim. So where do you even start with something like that? Well, that's the journey we're going on right now. We're going to trace how that initial spark, that gut feeling, was sharpened, challenged, and eventually built into a real, testable scientific model. How do you get from a simple, mind-bending idea like gravity is an illusion to something you can actually take into a lab and try to prove or disprove? So here's our game plan. We'll start with the radical idea itself, and then we'll introduce its absolute core concept, coherence. From there, we'll look at the engine that supposedly drives it, this thing called the open-closed cycle, and see why this all leads to challenging even Einstein. And finally, we get to the most important part. How does this become real science? And what are the mind-bending implications if it's true? All right, first things first, we have to make a big mental shift here. We have to try and forget the idea that gravity is all about mass. This new theory says something totally different. The idea is that gravity is tied directly to motion and organization. It's not just that things have mass, it's about how the particles inside those things are moving and arranging themselves that creates what we feel as gravity. And that brings us to the absolute heart of this whole thing, the principle of coherence. This is the key that unlocks everything else. The theory argues that it's not just any kind of motion that matters, but synchronized, ordered, harmonious motion. And this slide right here shows you the crucial difference. On the left, you've got just random motion. Think of steam molecules just bouncing around all over the place. Total chaos. But on the right, you have coherence. The particles are still moving, but now they're in sync. They're working together, like water swirling down a drain or a perfectly spinning top. So really, coherence is just a fancy word for a system's internal order. How well are its parts moving together? High coherence is like a perfectly tuned orchestra. Every instrument is playing in perfect time. Low coherence, that's just the chaotic noise of a busy street. And this is where it gets really, really interesting, because there's a real-world example. A spinning top is a system with incredibly high internal coherence, right? All its particles are locked into this one collective rotation. And because of that synchronized motion, it measurably, physically weighs less than when it's just sitting still. Now, it's a tiny, tiny effect, but it's real. And this theory says that's not just some weird quirk, that's a clue to the true nature of gravity. Okay, so if coherence can actually affect gravity, what's the mechanism? How does it work? Well, the theory proposes this dynamic engine that drives the whole process, a constant cycle between two different states, what it calls the open-closed cycle. This quote from the original dialogue really nails the idea. To actually generate an effect, like the lift for an airplane or to overcome gravity, a system can't just stay in one state. It has to have a transition. It needs to move from a closed, ordered system to an open, less ordered one, or the other way around. The airplane propeller is the perfect way to picture this. Think about it. The propeller itself is a closed system. It creates this highly coherent, super organized pattern of rotation. The air around it, that's an open system. And the lift, the magic, is generated right at the boundary, the transition, where the closed, ordered propeller forces a pattern onto the open, free-flowing air. That interaction, that jump from closed to open is what creates the effect. Okay, so we've got coherence, we've got this open-closed cycle. But following this path leads us to a pretty monumental confrontation. Because if this idea is right, it means the very foundations of modern physics might be incomplete. It means we have to go beyond Einstein. Whoa, now that is a bold claim, to say the least. But this isn't just about being controversial for the sake of it. This challenge actually comes from a real attempt to solve some of the biggest, most stubborn puzzles in science today. So why the challenge? Well, because our best models of the universe, for all their incredible success, have hit a bit of a wall. To explain why galaxies spin the way they do, we literally had to invent something called dark matter, this mysterious, invisible stuff that supposedly makes up most of the mass in the universe. This theory offers a wild alternative. It asks, what if there is no missing matter? What if the extra gravity we see is just the effect of highly coherent systems, like giant spinning galaxies, bending space-time more than their mass alone should? This is where the whole thing has to sink or swim. An idea, no matter how cool or elegant it is really just philosophy until you can test it. So the next step was to turn this intuition into a formal mathematical model that makes predictions you can actually go out and check. So the conversation had to shift from big concepts to hard equations. The goal was to build a framework that could make concrete predictions about the real world that could be proven false. Because in science, if you can't be proven wrong, you can't be proven right either. And here it is. This is the mathematical core of the theory. Now, at first glance, it looks a lot like the classic equation for gravity, but there is one profound change. The source of gravity, that rho f you see, the effective density, it isn't just about mass anymore. It now explicitly includes a term for coherence. That is huge. It means a system's internal order can literally add to or subtract from its gravitational pull. And this is the payoff. A real theory makes real predictions. The model says that if you can make a system's coherence go up and down, its weight should go up and down too. It predicts that if you have a sharp boundary between an ordered liquid and a disordered one, you should get a tiny lift force. It even makes predictions down at the quantum level with entangled particles. These aren't just vague ideas. They're specific, measurable effects you can test in a lab today. All right, for the finale, let's just zoom all the way out and look at the deepest, wildest implication of this theory. If coherence can shape gravity, what if it's even more fundamental than that? What if the difference between matter, energy, maybe even life itself is just a matter of degree, just different expressions of one single underlying process? This last quote from the dialogue really brings the whole vision together. It suggests that matter, energy, gravity, time, they're not separate pieces of a puzzle that just happen to fit together. They are all different faces of a single, unified process, the constant rhythmic dance of coherence. So we end on this question. What if the universe isn't really a collection of things, but a single ongoing process, a rhythm cycling forever between states of open exchange and closed organization, with gravity being nothing more than the shape of that rhythm? It's a radical idea for sure, born from a simple thought that leaves you wondering about the very fabric of reality itself.